I'd like to thank the American Humanist Association, through their Harvey LeBrun Chapter Grant Fund, is helping us give at least a little honorarium to some of our speakers starting now. So we really do appreciate them doing that, and hopefully this program will be a good one. All right, so now we're going to meet our speakers. We'll have Phil come up here. So Phil Torres is an author, musician, philosopher, neuroscientist. He's also an affiliate scholar at the Institute for Ethics and Emerging Technologies. Today we're going to be discussing his newly released book, The End, What Science and Religion Tell Us About the Apocalypse. Some of you met him a couple months ago with Dave Silverman was here. And then on the screen, this is Donald Prothero, is a geologist and paleontologist who's taught for 35 years. He's authored over 35 books, has over 300 peer-reviewed scientific papers. He's been on editorial boards of major journals, been featured in numerous documentaries, and we'll be focusing on his new book as well, Reality Check: How Science Deniers Threaten Our Future. I had the pleasure of interviewing each of these guys for Road to Reason over the last couple of months, and I think they would both agree that was the summit of their professional careers.
Very
anyway,
nice.
So welcome to both of you, and we have a seat and we'll get started. So writing about the end of humanity and civilization is not necessarily a heartwarming endeavor. Can you tell us how you ended up doing that, what you're trying to accomplish, what are the main themes that you tackle in your book?
Sure. People can hear me okay? So I was told that the microphone might be just a little muffled. So if you have any difficulty understanding me, please let me know. Okay. So yeah, the book covers a number of scenarios that have been called existential risk scenarios. Existential risk is a term that was coined by Nick Bostrom at Oxford University in 2002, I believe. And it essentially is defined as any sort of scenario that either results in human extinction or a permanent and irreversible state of stagnation. So the term in part is defined in the context of a view called transhumanism, which is very much related to, I mean, there are many points of contact with the humanist movement as well. But this view essentially believes that humanity is essentially a half-baked organism right now, and there are many modes of being that, through the use of technology, through the integration of technology with biology, humans could come to realize. So the notion of existential risk is either human annihilation or some sort of permanent stagnation. And most people are familiar, there are a certain number of risks from nature, like supervolcanic eruptions, one of which may have nearly caused our extinction 75,000 years ago or so. There's also asteroid impacts. NASA has a program that sort of keeps an eye on possible objects that could impact Earth and cause an impact winter. But there's also this sort of proliferation of new risk scenarios, some of which are associated with advanced technology, such as nanotechnology or biotechnology, synthetic biology, and so on, that it's just beginning to peek over the horizon, and more people are starting to talk seriously and as best they can rigorously about these risks. So the book covers basically all of this territory and then looks at the various agents who might use advanced technology to either through error or terror induce a catastrophe. And this is where religion comes in. I take it that the central notion of the sort of quote-unquote new atheist movement is that religion is not only wrong in a philosophical sense, but also dangerous. And perhaps the central takeaway from my book is that in the future, religion will only become more dangerous. I mean, all the aspects of risk that are associated with belief that's not tied to reality will be amplified and intensified by various advanced technologies. So that's the crux of it.
Okay.
Yeah.
All right. So Donald, we're jumping up. We're on slide number 7. Donald has to actually follow on his own set of slides there. So this is number 7, reality check. In keeping with the apocalyptic theme, I understand that ostriches don't actually do this, but if you'll allow the metaphor, can you spend a few minutes addressing whether or not burying one's head in the sand, or in molten lava in this case, is an effective strategy for coping with the inconvenient truths, or if we as a species desperately need a reality check?
As you probably can gather from the title of my book, Reality Check, I think we do need a reality check. And the basic idea is that we are now seeing warning signs from all over how the climate is changing. We just broke all sorts of records this winter. Warmest January, warmest February, warmest March ever recorded in human history, and all sorts of signs that this is not the norm. This is now extraordinary, and that we're going to run into some really, really big problems because we're already seeing countries that are disappearing under the water, those that are low in elevation. This is something you can't get around anymore. It's really obvious. And as you said, the problem is that, of course, these are an inconvenient truth, the phrase that Al Gore coined in his movie, but was very appropriate because people are very happy to accept science when it tells them what they want to hear, but they're often very reluctant to address science or listen to what scientists have to say when it tells them what they don't want to hear, whether it's that we are evolved from the rest of the animal kingdom or whether the climate is changing, we've got to change our ways. Those are messages that are hard for people to take. And they say, oh, well, scientists all cooked it up just to make grant money or to become famous. And I would argue that's just the opposite. The scientists are not killjoys, are not spoil sports. We don't do this just to get money to be becoming Cassandras. In fact, there's no incentive for us to do it at all, except that when the data tells us that something serious is coming along, you better damn well listen. Scientists, when they're telling you bad news, they're almost certainly telling you the truth because there's nothing to get gained from telling you bad news for us.
Okay. I have a problem with speaking really quickly, and as you've seen, Donald Prothero can speak 3 times as fast as I can. We have a little echo here, so we all need to try to remember to slow it down. I'll mention that and forgot. All right, moving on. All right. Steve, I don't know if we can adjust that because the top is getting clipped. Yeah, Steve, if you can do that. So by the end of today, Donald Prothero should be the... So Steve, can you get that projector so it lowers that down a little? By the end of today, Donald Prothero will hopefully be the first Donald that jumps to mind. So we're going to make Donald Rumsfeld here the other Donald. Phil, in the end, you present a host of existential crises that loom on the horizon. Can you walk us through the mode of categorization that Donald Rumsfeld talks about with known knowns and so forth?
Yeah, sure. So famously, Rumsfeld mentions known things we don't know and things that we don't know that we don't know. So there's a kind of a second order ignorance. And I think he was sort of widely mocked by certainly comedians. But actually there's really something, there's a bit of insight, a nugget of insight that he presented there. So in the book, I use the term monsters as a sort of playful moniker for unknown unknowns. And the essential idea is that it would be foolish to think that we have at this point delineated the entire space of risk scenarios. So I mentioned like ones from nature. Donald mentioned climate change. I would certainly add biodiversity loss. I feel like that's a risk that is quite significant. Some biologists have talked about it being our greatest legacy on Earth. You know, it'll last for many thousands of years, millions of years perhaps. And then also these various new technologies, some of which are still theoretical, such as nanotechnology. In particular, a version of nanotechnology that's called molecular manufacturing, which involves the manipulation of atoms one at a time to create, either macroscopic objects like a computer, or they could be nanobots that, for example, you might ingest and will get transported throughout the body. I think it was Feynman who said something to the extent of, wouldn't it be great if you could swallow the surgeon? So this is yet another, and you could find your heart or whatever and repair the appropriate tissues. So this is yet another kind of risk that is again on the threat horizon, sort of in the distance, but it really has only been discussed for the last probably 20 years or so. So it's really quite new. People at the beginning of the 20th century, for example, had no idea. So the point of that is that if you look transhistorically, you find that there's a trend of an increasing number of existential risk scenarios. So extrapolating this in the future, it would be foolish to think that there isn't going to be some future technology that right now is unimaginable to us, but also is dual use and introduces risks along with benefits. where these risks could be even more catastrophic than some of the technologies we have with us today.
I also like, you said he sort of left out one category inadvertently when he was talking about the unknown unknowns.
Oh, yes. There's the unknown knowns is the term he used, which this is a term that, what's his name? I'm forgetting just off the top of my, Zizek, I believe, came up with the term to describe the things that we know, but for various ideological reasons we have difficulty admitting. So climate change would certainly be an example of something that we know, but also is sort of widely rejected or
Right.
Yeah.
Right, and we've talked about some psychology issues here that will make us overlook something that may wipe out our civilization.
Yeah.
Let me see if there's anything else here. Oh, can you also, so I just wanted to ask the audience, if you guys had to predict what are the odds of humanity getting wiped out in the next, say, 100 years, are there any general thoughts where that would be? Is that 1 in 2? Is that 1 in a million? You know, what are your thoughts about the risks we face? Any takers?
Too many.
Half and half. 15. So that's depressing. Is that an accurate assessment?
Yeah, so let me just remind you that human extinction would be an extraordinary situation. I mean, there are uncontacted tribes in the Amazonian forest. There are people, it's 50 or 60 scientists, I think, in Los Estrellas, Antarctica. So really, to have a global catastrophe that wipes out humanity would be quite extraordinary. But that being said, I would say that if you were to poll the experts, people who study these issues, there are in particular 2 institutions, one at Cambridge called the Center for the Study of Existential Risk, one at Oxford University called the Future of Humanity Institute. There's also one loosely based in the US at MIT and in California called the Future of Life Institute. It's run by Max Tegmark, among many others. And if you poll them, I mean, they assign a really shockingly high probability, perhaps around 20%. Nick Bostrom has argued, he's at Oxford University, he's argued that 25% is probably the lower limit. And there's a cosmologist at Cambridge, Sir Martin Rees, who estimates a 50%, a coin toss for the next century in particular. So it's quite significant situation. And of course, there are one thing that I feel like is important to mention. Every generation has exhibited a tendency to believe that it is the last generation. So this goes all the way back to perhaps the ancient Persians, who were the first to construct the initial a complete comprehensive eschatological scenario, from which Judaism and Christianity and Islam borrowed quite a bit. So that is a caveat that I think one should take seriously. But that being said, a lot of the people who are making these estimates and talking about these issues are acutely aware of the biases and talk about, I think we'll get to the biases and heuristics later on, but are really make an effort to be aware of just how things like hindsight bias or representative bias or things of this nature influence and can distort their view of the future. So.
Okay. All right. I was just stunned to realize that it was that high. Can I get to Donald, then we'll come back with your question later. What we're going to do is we're going to go at this for about half an hour, then we'll stop and take some questions, then we'll keep going, and then do some more audience questions at the end. All right. So Donald, this next one is kind of a broad topic. Reality is not always pleasant, but it is what it is, whether we like it or not. And science seems like it's the best way to get a handle on that. So before we go through a bunch of the specific threats we face, can you talk about the fundamental difference between how you approach a problem as a scientist and how a creationist like Ken Ham might approach it? And maybe you can just kind of frame your whole discussion of science versus pseudoscience along that evolution-creation debate.
Yes, Ken Ham is fond of trying to pretend that what he does is science and that his method is parallel to ours, but in fact, there almost is no similarity at all. Ken Ham has a set of conclusions in mind already, namely that it has to fit the literal interpretation of the Bible, at least his literal interpretation of the Bible, and then he will bend and twist any evidence or ignore any evidence as necessary in order to make that happen. And scientists, by contrast, are not allowed to do that. In fact, we're just the opposite. We do not know what our conclusion will be, and we are supposed to be open-minded to following the facts wherever they lead, to whatever conclusion they lead to paraphrase Thomas Henry Huxley. And we're supposed to be open-minded to all sorts of facts that don't exactly go where we want them to go. And that's actually one of the powers of science, that we often discover things we did not expect, and often discover things that don't tell us what we want to know as well, but they are what they are. And so the scientific community doesn't have this idea of a fixed reality like Ken Ham does, where he has a truth that he's trying to prove. We have a set of lines of evidence and a lot of data, which we try to address the evidence and the hypotheses. We try to constantly shoot these down until the best ones are established. And then we only have a tentative idea what reality is still. Science is always open to further testing. It's always open to being shot down by any new discovery that comes along, which happens quite often to scientific ideas. And we never accept that we've ever reached the final answer or have a final truth. And that's about as diametrically opposite Ken Ham's thinking as you can imagine. And so this is a very different way of doing things. And one of the reasons we're confident this is a useful way to achieve some understanding of the truth, even if it's not a perfect one, is that it's always subject to testing. And it also has a built-in method of quality control and fact-checking, namely peer review, in which our harshest critics are allowed to tear us to pieces before we even get to print. And nothing survives peer review, at least not after a couple of rounds, that hasn't been pretty well vetted. And there's almost no other area in human thought anymore that has that kind of careful quality control. I mean, you look how unfiltered now the internet is, with every kind of garbage you can imagine out there, and no fact-checking or peer review. And science is one of the last refuges of relatively rigorous self-examination, peer review, and attempting to make sure that what we get out of that filter is something we really think is an actual real.
Okay, I want to ask you a specific question now. That Bishop James Ussher estimated that the Earth was 6,000 years old based on calculating back from Adam and Eve and going through the generations. As a geologist, how old do you believe the Earth is? What do you base it on? And does that comport with your studies of flood geology?
Well, I wrote a whole chapter on that topic too. But basically, we scientists don't believe something. We have evidence for something. That's first. I don't use the word believe in science. And we have a lot of evidence for that the Earth is 4.5 to 4.6 billion years old. That comes from a variety of lines of evidence. It comes from several different isotopic systems and how they decay, which is called radiometric dating, including rubidium, strontium, 2 forms of uranium, lead, and potassium argon. It comes from moon rocks, and also comes from meteorites that were formed in the early solar system about the same time. And so all of this is many lines of evidence, all of which are completely independent, all of which converge on the same answer. And the odds that that is done by some kind of a miracle or accident is infinitesimally small. So that's why we're confident that it's a very robust result, although we don't believe in anything in science, okay, strictly speaking. And flood geology is just basically an attempt to shoehorn all of what they can see in the rock record, which is not much, into the Genesis accounts, the 2 of which in Genesis 6 are actually from different sources, don't even agree with each other.
And so do you have any approach when you run into people that insist that science is just another dogma, or you're being dogmatic in your assumption that evolution is true? Is there a particular way you can break through to them, or students especially, to lay out that science really is a different, a more reliable approach?
The best approach I can think of is just show them evidence. I mean, for hardcore creationists who don't want to listen, nothing will reach them at all, and I don't really expect it to. But what I found when I wrote my 2007 evolution book, what did reach was people who had sort of a vague idea about evolution and had been exposed to creationism in their churches, but really weren't committed to either viewpoint. And when they saw the power of the evidence in the fossil record, in my case, as a paleontologist, that was the focus of my book, it was very convincing to them. And that's really the best ground is made. It's people who are not hardcore, because you don't reach the hardcore, but people who sit on the fence and not sure what they think can be convinced if you're persuasive and not too threatening and not too condescending, and also if you just give them lots and lots of evidence that forces them to back off, a dogmatic viewpoint. I mean, the same way Bill Nye approached Ken Ham during the debate a year and a half ago. Instead of attacking Ken Ham directly and going after every single claim he made, as the Dwayne Gish used to do, the Gish Gallop, Bill very smartly just showed how absurd the logical conclusions of their viewpoint were and how ridiculous it sounded when you thought about it rationally. And I thought he did a beautiful job in making Tin Ham look foolish.
Okay, all right. Let's see. All right, so Phil, you keep a very upbeat tone through your entire book despite the very difficult subject matter that you're talking about. Can you kind of walk us through your own thought process of when you're evaluating a risk, how much resources we should be allocating to that? How do you think about risk with probability and the catastrophic effect it might have?
Yeah. Actually, may I add something just real fast to what Donald said? So up here we have the book, a book written by Peter Boghossian, and while I completely agree with what Donald mentioned, Boghossian has a very interesting point that oftentimes when you debate someone about politics, particularly if someone is partisan, or you debate them about religion, presenting them with facts and evidence can end up being otiose and sort of pointless because they have to value the evidence. They need a basic understanding that this comes into play in particular with conspiracy theorists who tend to look at a particular bit of evidence that supports. When you need to look at the totality of evidence and see what the totality supports. And I believe Donald mentioned this in his book, that there are various hypotheses out there that may actually have positive evidence from certain domains, but really the rational individual doesn't pick the hypothesis with supporting evidence. He or she picks the hypothesis with the most supporting evidence relative to the alternative views. So I think it's, one thing that Boghossian emphasizes that I think is extremely helpful is asking people why, or how do you know? So ultimately to get down to the foundation of their epistemological theory that they accept. And then if you tweak that a little bit, if you instill in them, for example, a passion for evidence, for coherence, and so on, then presenting the facts is the easy part. So as for your question, in terms of weighing risks, on the one hand, there are some objective statistics that you can use to estimate the probability of certain risks from nature, such as an impactor striking Earth or a supervolcanic eruption. Some of the estimates that I mentioned in the book, a supervolcanic eruption goes off every, I'm sure Donald would have much more information. Every 50,000 years or so, I have a citation for that. An impactor that could destroy, a society or something strikes Earth half as often as a supervolcanic eruption occurs. So those are pretty robust estimates that you can make about our sort of existential plight. In terms of climate change, then, there's also fairly good science.
Well, let me just jump before you get off that. So let's say there's a 1 in 100,000 risk this year of us getting hit by a catastrophic asteroid. Is that reasonable just to ignore it, or does more go into your calculation?
Well, I think, so part of the issue that has to be looked at is a risk typically is defined as the probability of an event multiplied by its consequences. So that means if you could have a large risk even if the consequences are low but the probability is extremely high, or vice versa. You could have a significant risk if the probability is very low but the consequences are huge. So in the case of existential catastrophes, or even a global catastrophe that, a billion human deaths would be an unthinkable tragedy. So the consequences are so big that there's a fairly cogent argument to be made for why allocating resources to reducing the probability that such an event happens is a good use of resources, even if it's highly improbable. So,
right. So I think one of the points there, and Donald, you can jump in on this. As a scientist, if we're driven more by science, do you think it would be a better way to run society if the government looked at exactly what he said? Here's a low probability event, but the risks are catastrophic, and then weigh out some kind of procedure to allocate our resources. Right now we seem awfully anti-science-y.
Yeah, it's ironic because we have almost no real science effect in our government. And of course, we have science deniers running the House Science Committee, and also science deniers running the Senate committees, which fund science in this country. So it's a very tragic thing. And you can contrast that many other countries in the world, their leaders are actually trained scientists, including Angela Merkel, the premier of Germany, and leaders of many other countries are trained scientists. So it's one of those strange twists where we have this weird thing about science where we love what science gives us when it gives us electronics and good health and all these other things, but we aren't willing to listen to a scientist when we really need to.
Yeah, it's almost, I don't know if have you been following, like trying to get a presidential science debate? I haven't seen anything on that in the last month, but
There haven't been much science in the debates at all. It's been one of the big problems. Yes, right.
no, but I mean, like they were trying to get the presidential candidates to do a science debate, and
Right.
it seems like they've
Dedicated
all,
that topic, yeah. And so far, I don't think it's going to happen the way things are going with the current season. So,
Incidentally, I don't know if people have seen, but just maybe 2 days ago, the Canadian leader, Justin Trudeau,
Yeah.
he was asked this question about quantum computing and gave a surprisingly coherent and erudite answer, I would say.
yeah,
It
yeah.
blew me away. I mean, certainly if you juxtapose him with what's going on, sort of on the political right of the U.S., the difference is really striking.
Yeah, very different night and day in our leadership. Yeah.
All right. Now, we've talked about, with Peter Boghossian, we've talked about doxastic closure as the idea that people don't want to, if you just don't want to hear it, you're just not going to listen, you can't make an impact. You also talk about cognitive closure.
Yes.
In terms of, can you go into that, and how that ties into our discussion about existential risk?
Yeah, sure. So, so doxastic closure is the situation in which your web of belief is closed. It's not open to revision. Cognitive closure, although terminologically it's somewhat similar, the notion is quite different. It essentially, the essence of the idea is that human beings are animals. We're a member of the animal kingdom, just like dogs and squirrels and so on. These organisms have evolved over long stretches of time to survive in the particular environments in which they lived. So as a result, the mental mechanisms that they have, here's a good way to put it. So one of the pictures that philosophers accept is there is this external world, which is often described as mind independent because it does not depend on the mind in any way. And inside our skulls is an organ that produces representations of the outside world. Truth, for example, is a relation between, is typically defined as a relation between a mental representation and a state of affairs in the world. And when there's an appropriate correspondence or isomorphism between them, that's when you have a true statement or true thought. So the notion of a concept is a mental representation of some feature of the world, the concept of a chair, the concept of an electron, and so on. So the brain has these evolved mental mechanisms which generate concepts. And just as the brain of a dog, for example, is limited in the number of concepts that it can generate. So for example, no matter how hard you bring a dog, you tutor a dog to sort of grasp the concept of the stock market or an electron cloud or something, it's simply not going to get it. So in that sense, philosophers would say the dog is cognitively closed to those concepts. It's cognitively open to the concept of perhaps, food or cat or something like that. So by analogy, there's no reason to think that the human mind is cognitively open, that we can generate every concept, every type of concept needed to represent every type of phenomena in the world. So classic examples of this, a philosopher named Colin McGinn wrote a really extraordinary book on cognitive closure and went through a number of problems which have so far proven to be more or less perennial. Whitehead once said that all of Western philosophy is a footnote to Plato, and that's absolutely true. And so these are perennial questions that Plato himself talked about many millennia ago and are still major issues talked about in philosophy departments. So Colin McGinn has claimed that a lot of these are questions that we can ask, but we cannot in principle answer. because we're cognitively closed to the appropriate solutions to these problems like free will, the nature of consciousness, and so on. So to recap, I mean,
And I assume there's also some problems that we're not even aware of enough to pose the question.
precisely. So you might create sort of three categories. One is questions that we can ask and answer. The other is questions perhaps that we can ask but not answer. Or perhaps there's some issues in quantum mechanics, like at the very vanguard of our understanding, that will never be answered. Richard Feynman again famously said that a claim that nobody understands quantum mechanics. Like we sort of understand it mathematically, but not conceptually. And then there could be issues that are to us close to the point that we cannot even ask the question. In exactly the same way that it's not that your pet dog wanders around going like, I really wish, it's such a shame I can't understand the stock market. It has absolutely no idea, and it will not have no idea. So the whole idea with cognitive closure goes back to the unknown unknowns, that there could be a subcategory of unknown unknowns that are unknowable, in principle. There's no reason to think that our brains can mentally represent every type of risk in the universe, just as the dog is unaware of the ongoing threat of an asteroid impact. Perhaps there could be, so it's quite a speculative argument, but in my judgment at least, I feel like there's some robust reasoning that leads up to make the conclusion at least plausible enough to take seriously.
Yeah, and we can talk about that more when we get to artificial intelligence and how to get around that problem. All right, Donald, we're up to slide number 11, Chuck and Dave's think tanks, or premium think
I'm
tanks.
there.
So you write about a playbook that a bunch of people in the denialist movements share. Can you, and I don't think people can read that, but that's Holocaust deniers, AIDS deniers, climate change deniers, evolution deniers. So can you kind of walk us through those playbooks?
Yeah, it's quite interesting. But when you get any of these groups of people that want to deny what is really well established scientifically and in terms of factual content, they almost always resort to the same strategies to try to either deny or at least distract people away from what that idea thinks. And so what they'll have, for example, is what I can call the Holocaust Holocaust deniers playbook, because the Holocaust deniers are pioneers. Here's an idea where we even have the survivors of the Holocaust still around, although sadly dying off all the time. And the Nazis themselves bragged about their efforts to kill Jews and Poles. So it's not exactly something that's not well recorded. And yet there's a small group, a very determined group of people who try to either deny the Holocaust existed or to claim it wasn't as big as the evidence shows it was. And they use all the same strategies creationists use and the climate deniers use, namely trying to do things like pick on differences between scholars, quote out of context, quote on one fringe scholar against another. There are all sorts of strategies where they completely distract the audience and they miss the forest for the trees because they do all these sorts of misdirections from the actual evidence that's so overwhelming. And then a very interesting book in 2010 came out by Naomi Oreskes and Eric Conway called Merchants of Doubt, which showed that there's another element of this. It's called smokescreen strategy, and it was actually pioneered by tobacco companies in the 1950s in a famous memo written for them by a PR firm called Hill & Knowlton. One key phrase was, "Doubt is our product." And the tobacco companies managed to escape blame and prevent their sales from declining for nearly 50 years after it was clear that smoking caused various types of diseases, especially lung diseases, by constantly sowing doubt and by suppressing any research they could. And so they actually had their own researchers who were proving to them that, in fact, their product was dangerous. And all that research, of course, they held completely secret because they themselves had paid for it and they had that right. And so it wasn't until about 99 when Congress finally used the Racketeering Act that they used to break up the mafia. They finally got the tobacco companies to admit on the record in front of Congress that they had done these things, or at least to perjure themselves and claim they didn't know they'd done these things. The same has now been revealed with the oil company leaks. ExxonMobil, about a year ago, has now been revealed to have known about the evidence for global warming since the 80s, and their own scientists were producing it, and they suppressed this evidence, instead spent their money trying to create smoke screens and create a political machinery to prevent people from believing global warming. And now it's looking like Peabody Coal and these coal companies just going out of business right now. Their records are now going to be open once they are in bankruptcy court, and we'll be able, and people have already discovered there's evidence. These coal companies also knew the fact that coal causes global warming, and were spending money to basically prevent that fact from being known. So it's a very clear case of conspiracy there to suppress the truth. And this is the kind of smokescreen Conway and Morris, Conway and Oreskes have talked about. And so that's something that's very scary, because it shows you how easily an entire public can be misled with a very well-funded PR campaign.
Can you tell us about the specific role that think tanks or pseudo-think tanks, from the Koch brothers or whichever right-wing ideologues you want to pick, tell us about the role that they do in informing or misinforming both the public and the media?
Well, the basic idea is that the think tanks are not as independent as they claim to be or as appear to be. They're all basically funded, and now thanks to various Freedom of Information Acts, you can look them up online who pays for them, and they're always paid for by the same culprits. It's usually the major energy countries, fossil fuels countries, or companies that are trying to support these denialist efforts, along with a number of right-wing organizations that have vested interest in trying to prevent things like environmental laws coming in. So there's usually two motivators. It's the energy companies who want to prevent regulation, and it's the various hardcore capitalist libertarians who don't want the government to do anything. They're the ones that fund these think tanks, and then think tanks act as their mouthpiece to spread these ideas, and you don't realize the fingerprints of oil companies are all over these guys when they're talking on CNN or Fox News or whatever.
So, Phil, would you lump the think tanks in as an existential crisis? I mean, how big of a problem is it that we get our information from them?
Indirectly. I mean, without a doubt that there are a lot of problems there. I would add also that there's a huge difference between, when we talk about risks to civilization or humanity, there's a big difference between being alarmed and being an alarmist. And it ultimately is epistemological. It has to do with the extent to which one's fears are properly proportioned to the best available evidence. So, this goes back to something I'd mentioned early on about this long history of every generation believing it's the last, and all of them being wrong. I mean, there's really innumerable prophets, which perhaps we could talk about, starting with Zoroastrianism through Jesus, through Muhammad, and so on, who believed that the end was imminent. Today, though, this situation is different because we do have a scientific methodology that enables us to properly proportion our fears to the evidence, and it turns out when you do that there really is good reason to be quite concerned about some big picture hazards, such as climate change and biodiversity loss, and perhaps even the more speculative risks that I go over in the book as well. So.
Hey, Steve, could you get the circulating mic, and we can maybe take a few questions from the audience? Phil, I'm going to start you with one more. We'll see how quickly we get the mic going.
Okay, sure.
And Donald, this is going to be for you also. This is a joint question.
Okay.
So this is for anybody who doesn't think that we're really in trouble and thinks that the end is just another alarmist cry, as you talked about, from a tree-hugging liberal. Can you guys both tell us about mass extinction number 6? What sets it apart? Why is it exceptional?
Donald, do you want to?
Yes, we paleontologists have sort of identified 5 huge mass extinctions in the geologic past, 5 that really stand up above the background level, including the one that killed off the dinosaurs 66 million years ago, and the biggest of all 250 million years ago, which we'll probably talk about. And of those 5 are quite well documented, and quite a lot is known about them now. And then what has been clearly pointed out is that in the last 1,000 years or so, we humans are the primary cause, or we and our agents like cattle and climate change and rats and so on are primary agents of extinction number 6 that is thought to be now as bigger than anything that happened in the geologic past, in the sense that we're wiping out huge percentages of land mammals, land birds, many other things, at a rate that is much faster than we can tell ever happened in the geologic past due to natural causes. And so we call that now the 6th extinction, and it's a really alarming thing because we were doing this for centuries, of course, as we wiped out animals all over the world as we explored it. But now it's becoming obvious that just the imprint of humans alone is making the planet uninhabitable for most of the rest of our fellow travelers.
Yeah.
Is he on the fringe, or is this a prevalent view amongst geologists and biologists?
No, Donald is not on the fringe. So yeah, I would just add that I mentioned earlier that perhaps, and maybe Donald has some thoughts about this, that there's some biologists who think that the Holocene extinction event is what it's called. Although some people also think it might have began all the way in the Pleistocene
Right,
with
right.
killing off the megafauna. That this is probably the greatest legacy because this will take a huge amount of time in the future for nature to bounce back, for the biosphere to bounce back after this huge trimming event. And I would also add that biodiversity loss, biodiversity in general, is a concept that encompasses not only the number of species, but the number of individuals within a particular species. So you can have biodiversity loss that's significant, for example, even if you don't have any species losses. So right now, the sixth mass extinction refers to the disappearance of a huge number of species, 100s, perhaps 10,000 times the background rate of extinction. And in addition to that, there's also just massive loss of populations throughout the world. So there are a number of really comprehensive studies that have been done on this, like the Global Biodiversity Outlook Report. There's also the Living Planet Report. And for example, Living Planet Report found that between 1970 and 2010, the global population of vertebrates declined by 52%.
Yeah.
So, and people are. I've talked to several scientists about the reasonableness of extrapolating the number into the future, and all of them are a little bit afraid. But actually, there was an article published in Nature in 2006 which extrapolated current trends of marine biodiversity loss into the future and found that by 2048 there would be essentially no more wild-caught seafood. Mm-hmm. So the rate of amphibians in particular are declining at a rapid rate, and sometimes they're considered ecological indicators, which are more sensitive to perturbations in the environment. So and therefore are sort of canaries in the coal mine. But really, just the raw data is stunning, and yeah. And I in my own work, I write for Salon, and I actually just published an article in the Bulletin of Atomic Scientists about biodiversity loss, because it seems like an issue that, to me, is not very well known and really ought to be. Because again, the numbers are quite staggering.
Yeah. So we'll come back. I want to talk about that, why it's not better known. And Donald, I want to ask you about the ocean. But first, can we take? I think Abhi, you had a question. Hold on, you got to do it into the mic so we can get it recorded.
Mine was sort of a question, but then also a little bit of general commentary. And I think when we had talked about pseudoscience and mentioned that, and then Dr. Prothero had mentioned how much junk is on the internet, you can kind of take pseudoscience, the junk on the internet, add those together, and then just, of course, regular lack of knowledge in mainstream society and add that in. And all of that has had such a net effect on the way people perceive the truth or how they rationalize things. I'm a primary education, I teach high school science, and just seeing the way that these kids conceptualize certain things because they go on the internet, and now oftentimes what's happening is they're confusing science with pseudoscience, and it's very difficult for them to separate those. So I just wanted to maybe get some more thoughts on that and what would be a way forward. And I think Dr. Prothero mentioned that, in our government, there aren't too many officials who are in positions that have a science background, whereas in other countries it's a little bit different. And the mainstream American public generally only tends to advocate for or cheer on science if it has some direct application to something that they see, that's usable. Otherwise, science is bad and some type of, goofy dysfunction in society or something like that. So I think that has become somewhat of a bigger issue. So, thanks.
Let's see. So, Donald, do you want to? I don't know if either one of you want to take that. What are some practical ways that we can help lay people start differentiating pseudoscience and all of the noise from genuine scientific concerns?
Well, it's tough because pseudoscience does a very good job of presenting itself as if it's scientific, and especially on the internet, if you're just browsing websites, it's hard to tell them apart. Other than crank sites tend to use certain very garish colors in Comic Sans font. That's usually a giveaway. But the basic thing is that you should look deeper. I mean, the best way to look for it is to start doing some research and finding sites which are reputable, especially if they come from accepted peer-reviewed scientific journals, which also are available on the internet. And then you can to quickly decide if these things are real or not. And so that's one of the best ways to go about it. I mean, you just have to dig deep enough that you can quickly tell if a website is a crank or pseudoscientific or whether it actually represents something that's reasonably close to what scientists think.
Phil, do you have any thoughts or maybe about just education, getting people to understand what peer review is, but not just for academics, but...
Yeah, I think one of the most significant challenges is instilling in young people an ability to differentiate reputable websites from ones that aren't. I mean, I genuinely think that is a huge issue. There's an exponential profusion of information out there. So for example, if one measures individual ignorance in terms of the difference between what one person knows and what humanity as a whole knows, then if you look over the past 200 years or so, there's been an exponential increase in ignorance. So in proportion to the growth of collective human knowledge. So that puts us in a situation where anyone, even the most polymathic individual, knows only a tiny little segment of the universe of what we comprehend at this point about the universe. So this is where the sort of division of cognitive labor comes in, and ability to recognize the necessity and the nature of expertise. It's okay to not know something. Everybody's ignorant about most things that there is to know these days. So the trick is to I think teach students exactly what you're saying. I think it's really, really important. We're in this situation where you are just going to be profoundly ignorant, but that's okay because you embed yourself in a network of knowledgeable experts and you rely on them just as they might rely on you for some sort of expertise. And that is how, once you're able to do that, you can sort of navigate the world in a rational way, despite the fact that you don't know, most of what humanity knows. Yeah.
Any other questions?
Can you hear me without the mic?
No, we need the mic to go through the audio system.
Okay.
Thank you.
Sorry, I'd rather talk without the microphone because I think it's easier to hear. And you had talked about that there wasn't going to be anything to 2048, that there was not going to be. Can you repeat that? I wasn't able to catch it.
Sure. So the claim made by a 2006 study published in Nature said that if current trends continue, and they're quite careful to note that things could change, new policies could be implemented that preserve biodiversity loss, but if trends continue unabated, it's a simple extrapolation to the future that by 2048 there will be essentially no more wild-caught seafood.
Okay.
Yeah, that's the...
The other question I had is that between pseudoscience and real science, isn't an important concept the idea of falsifiability, whether a concept can be falsified? Can you talk about that a little bit? I've always found that to be a helpful concept whenever I try to sort through some data.
Can you talk about that, the importance of falsifiability for any claim?
Sure. The falsifiability claim is a famous one that Karl Popper, a British Austrian philosopher, made about 50 years ago now. And it's not perfect for all science, but it's a very good first approximation of how to tell pseudoscience from science, because most pseudoscience will make claims that if you look at them carefully, you find there's no way they can be tested in order to be shown wrong. So like astrology, for example, make claims that you will have a good day today. And that's so broad and so vague that there's no way to test it and show it's wrong. And that's same with a lot of other kinds of pseudoscience. They'll make very broad claims that have no place where any observation can make them show them wrong, and that's why we treat them as pseudoscience. So that helps a lot for a lot of the kinds of things like astrology and like weird ideas that are out there. A lot of them are basically so all-encompassing that no amount of any evidence would ever falsify it, and that helps people see that therefore it's not scientific.
And maybe you just point out a couple of quick things that could falsify evolution, because there's claims that people just hold that dogmatically, but what are a few things that would make us rethink if evolution was true?
Oh, there are lots of things. The famous phrase, if you can find a rabbit fossil in the Precambrian, in other words, something that shows the total geologic order is not working, that would falsify at least a big part of it. And just any number of experiments that show that the evidence is not in support of evolution would do it. But what you have to be aware of, though, when you're talking about an idea as well established as evolution, the burden of the proof now has shifted. When Darwin proposed it in 1859, the burden of proof was on him to show that life had evolved and that he had a mechanism, and that was what he did, and people did in the next century and a half after him. But now there's so much evidence in support of evolution that a single a weird observation isn't going to falsify evolution all by itself. It would have to be quite a few falsifications of a lot of lines of evidence to show us that evolution does not in fact work.
And anything that creationists throw out, if you say, how can we falsify creation, is there anything that they float out there?
Well, they don't talk in those terms at all, and they're not used to thinking about anything being refuted. Remember, they're absolutist, and they have their conclusions in mind, so they don't allow any possibility that what they are talking about could ever be proven false. In other words, if you show them their ideas are false, and there's lots of them, of evidence, you could do that very easily. They always have a rationalization. They always have an out. They're always willing to find a way to rationalize and justify what they already believe. And that is a classic case of a pseudoscientific or non-scientific way of operating. Because a scientist, as Richard Feynman said, has to be willing to give up even their most treasured notions if the evidence goes against them. We're not allowed to be emotionally attached to our notions.
I think we had one up here.
May I add something real fast to that? Just perhaps a helpful way of couching this situation, it very much ties into falsifiability, is, for science, beliefs are, as Donald gestured at earlier, they are not your points of departure, they're the destinations. And the journey, the way some philosophers have put it, evidence is a fallible guide. It certainly has led us astray before. But it is, it is nonetheless the best guide that we have. So philosophers, say, follow the evidence. It's the best guide to truth currently available. And so ultimately, you begin in a state of ignorance, and you move towards various beliefs, allowing the journey to be pushed and the course to be shaped by the evidence. Whereas with religion, oftentimes it's the reverse. You start with a set of beliefs, and all your energy goes into defending these initial, immutable doctrines from new research and new evidence and so on that threatens to overturn and to vitiate your initial beliefs. So, and that very much ties into falsifiability, because when your beliefs are in the future, you have no commitment to them, prior commitment to them. Then you come along and you think, evolution appears to be a fact. And then you find a Precambrian rabbit, and you realize, well, it's, at least the picture's more complicated, if not completely wrong. So what? That's the way it works.
Right.
Yeah.
Okay. All right, Steve, we had one up here.
I want to go back to human intelligence for a minute, because I'm fascinated by the idea of there could be things out there that we aren't even aware of and couldn't be aware of because we're incapable. I've used that analogy before about teaching your dog to run the stock market or program a computer.
Yeah.
There was I forget who the researcher was, but there was somebody talking about wanting to start a project of genetically modifying humans to make them more intelligent. And blogger P.Z. Myers was taking him to task for not only the ethics of that, but how unworkable it would be. And he was talking about our intelligence has basically been the same for the past 50 or 100,000 years, and if you took an infant from that time and yanked them into the present, that they would be able to grow up just like we are for the most part. And prior to that, our intelligence was evolving so slowly that it would take 1 million years for us to come up with a better cutting tool. So, whatever it is that happened 100,000 years ago, must have been, extremely fast, but then it stopped and we haven't gotten any smarter. So the question is, have we reached some kind of limit that, it seems like if more intelligence was a good thing, we would have kept getting smarter, but we haven't. So based on our brain size, have we reached some kind of limit? Or I just wanted to get your thoughts on why things haven't changed for so long, and also what the possibilities would be for genetically manipulating somebody to be smarter, which Professor Myers thought would, involve thousands of genes or at least hundreds and just be an ethical nightmare to try and work out. So,
yeah. So a couple things to say. First of all, a quote from Ernst Mayr comes to mind. He once said in a debate, I believe, with Carl Sagan, that intelligence is a lethal mutation. So I mean, and incidentally, there was also a Stanford geneticist who recently talked about, recently proposed, and I haven't actually read it in detail, but just as a side note, which is perhaps interesting, he claims that there have been an accumulation of mutations that have actually compromised our intelligence over the past several millennia. So, perhaps people could look this up for further information, but he claimed if you essentially took someone from ancient Athens and plopped them into modern society, they would appear to be the most intelligent, knowledgeable, capable individuals around. So perhaps there's a kind of dysgenic, so to speak, phenomenon that's been going on for a while, since the rise of civilization. I would say that P.Z. Myers is right about the complexity. I mean, there's no, just like there's no gauging, there's a whole multiplicity of different factors along with environmental factors as well that result in the particular phenotype that you have. So I think probably, directly manipulating genes in order to augment our intelligence seems pretty tricky. And there's also an issue in terms of like brain size between the problem of birth and our size. So I mean, we're essentially, a lot of organisms gestate until, when they're birthed, they can walk around immediately. We essentially are birthed in the middle of that process. So we're helpless for, the first couple years of life because we're still doing the development that other mammals do inside the womb. So, and that was a result of a compromise between the width of the pelvis. The wider it gets, the more difficult it becomes to maneuver, and then this evolutionary pressure for larger brains. So perhaps we've reached, some kind of equilibrium with respect to that. But that being said, there are a number of techniques that people have talked about which are still experimental, which would involve modifying the human genome to create far more intelligent biological organisms. So one that I talk about in the book. Yeah, sure.
I want to rephrase that question and
Yeah.
have Donald answer. And then
Oh, sure. Yeah.
So Donald, are our brains more belief-generating engines or truth-identifying machines?
Well, it's a hard question to answer because all we know about prehistoric brains is the size of the volume of their cranium. And that doesn't necessarily equilibrate to just how intelligent they are or how complex their thought processes are. I mean, that part has been pretty stable over time, as people have noted. And as you already noted, Phil noted, that we have a constraint we have to worry about, which is allowing our brains to get larger in physical size is a problem for our birth canal and the female's birth canal. So there's reasons to think that we don't really know whether we're necessarily more intelligent in the past or less intelligent in the past. And I would say that that's really something, it's more speculation than something we really have a hard handle on.
What about I'm not sure if you heard that. What about the main evolutionary driving force for our brain? Is it to identify the truth, or is it to help us sort of get along in a social situation? And can everybody hear? I can't tell if this is on.
Yeah, you're on. I can't hear you again.
Sometimes it cuts in and out, but most of the time, yes.
Okay. Maybe you can do that question again. Are you able to hear me now, or we're going to
I hear you now. Yeah.
I'd be happy to address that. as
Go
well.
ahead. Go ahead.
Um, so, well, perhaps I should finish my thought before in terms of whether or not it's possible to have an organism with a human being with a larger brain. So this is different than various cyborg-related possibilities, which would be the integration of technology through a brain-machine interface. There's several other options in addition to that. But so there's an idea that's been discussed. It's still very much theoretical, but it seems to be plausible, which is called iterated embryo selection. And this has to do with deriving embryos from stem cells. And the exact process, which is somewhat convoluted, eludes me at the moment, but essentially the idea is to create an array of embryos, select the ones that fit a genetic profile the closest, where that genetic profile is identified based on its probable intellectual properties. So you select those embryos, and then you derive stem cells from them, and grow another batch of embryos, and continue to do this. And so Nick Bostrom actually wrote an article about this recently with Carl Schulman, I believe, and they did some calculations and discovered that over, maybe 30, 100 iterations, you could have, a set of embryos which would very likely, under the right environmental conditions, grow up to have IQs of, 140 or beyond. And beyond that, it sort of gets murky what the difference between 190 and 180 is or something. But so that's a way of manipulating the genes, sort of using a kind of, essentially the mechanism of natural selection, except it's not nature doing the selection, it's us, based on an artificial human-chosen environment, namely the smartest organisms are the ones that end up surviving. So that's a possibility as well, and perhaps much simpler than actually tweaking the huge array of genes that are responsible for this really, the most complex object in the known universe, our brains.
All right, any last question, or should we get back to slides? Okay, we'll do one more question, then go back to the slides, or two more. Fine.
Hi, I'm just curious, going back to forward to the sixth extinction, are we seeing any signs of any animals and plants who are beginning to adapt, with the possible exception of bacteria? With global warming, it's virtually a fact. What is happening in the natural world in response to that?
Donald, can you take that?
Sure. There are lots of organisms that are very flexible and opportunistic. They're sort of like weed species that thrive when conditions are bad for everybody else. And we see this happening. We look at all the previous 5 great mass extinctions. In the period of time, the aftermath of mass extinction, what you find is a huge number of just a few species that take over the almost vacated planet and flourish like weeds do in a disturbed habitat. And so they are very specialized in doing that, and then they usually tend to be crowded out once new forms evolve that can tolerate the new norm. And so in that respect, you could look at some of the species that humans have let loose on the planet that should pretty much thrive everywhere, from rats to the various kinds of insects like cockroaches that we have gotten spread everywhere, to all the various introduced goats and things like that, which are, of course, our plague on the planet. And even the tendency of certain organisms which were already there but are taking advantage of the disturbance we've created, like the migration of various disease-carrying mosquitoes to places where they weren't before, and various other kinds of pests. So it's not so much that new things are evolving in response to climate change as that things which can take over a new habitat and take over a new niche that wasn't open to them while there was a different weather or when there were other species in the way. Or in the case of what humans do, we have species which are super hardy, like cockroaches and rats and goats, which every time we introduce them just about any other place on Earth, they drive out all the natives to extinction. So that's really what we're seeing. It's not so much evolution of new species in response to it, but the species that are very adaptable, like weeds, end up becoming everywhere.
Yeah, I would just add that a lot of skeptics, but point out that natural there's a natural cycles of variability in the environment, and that's absolutely true. First of all, I would say that nobody knows that better than the climatologists and the scientists. So that's certainly something they take into consideration. But also, I mean, the crucial issue is not the change per se; it's the rate of change, right? So it's that evolution. You mentioned bacteria. I mean, they have their new generations are created very rapidly, but for other organisms, it's evolution operates on this very slow transgenerational timescale. So the issue is that the change is happening so fast that evolution, this very slow grinding mechanism, simply can't keep up, and that's when you end up with these species extinctions. And yeah, and I agree with Donald's point about weeds, and there are these organisms that tend to thrive in disturbed environments. So,
Jason?
I was just going to say, in regards to the comment about why we don't get any smarter, or why we haven't gotten much smarter, I wasn't sure if there's much of an evolutionary pressure for it, because it seems like we're well adapted enough and smart enough. There may not be pressure except from your teacher at school or your boss or your mom to get smarter. And also, I didn't know that it's not necessarily how big our brains are, it's the connectivity inside. I mean, there's this great disparity between humans right now in intellect, and it's not because someone's head is twice as big as the other. So it's not just the size that will make us smarter.
yeah, I think that's absolutely true. I think it's the case that Einstein had a sort of small brain, but the number of invaginations on his neocortex was so. Yeah, brain size. It's EQ, encephalization quotient, is sometimes perhaps a better measure. How big the brain is to the body. I would also say that in terms of the pressure, pressure from your family or your boss or something. So that sort of pressure that happens within an individual lifetime is not necessarily relevant to evolution. When you're talking about evolution, you're talking about the relation between some property like intelligence and the number of offspring you have. So it's a population level phenomenon. And if you were to, the Lamarckian fallacy is this notion of like if you study really hard and become very smart, then your kids will be smarter as well, which is not the case. So. Yeah, I think the relevant issue is I should also add, so anthropologically speaking, there was about 2 million years ago or so, the exact number is disputed, that's when the first Homo, the genus of Homo emerged, with Homo habilis, and Homo habilis translates as the handyman. And that, in the archaeological record, it roughly coincides with the first stone tools or lithics. And the idea is that this was perhaps the initial intelligence explosion, and it probably had to do with, or at least some people have speculated, had to do with the creation of stone tools. That suddenly there was this pressure to have the cognitive capacities to manipulate stones, using other stones to create weapons, essentially to augment your phenotype to survive better in the African savanna. So there perhaps was initially this pressure to develop larger brains. Homo habilis looks very similar to the previous, also called gracile Australopithecines. Looks very similar. It's not until you get to like Homo erectus. Neanderthals, in fact, have had larger crania than we do. But just so initially there was perhaps this pressure to become smarter and smarter as a result of tool use. And at some point it sort of leveled off, and then according to some geneticists, it sort of declined a bit the past several millennia. So.
Okay. Donald, anything that you want to add on that, or can I?
No, that's fine. Go on to the next question.
Okay. All right. So I want to get back to extinction. So I think it was Peter Ward. I can't read it. It had written a book, The Green Sky, about the Permian extinction, also known as the Great Dying. Where I think 95% of all species went extinct. And that did have to do with climate change, but he noted that the main catastrophic event was the acidification of the oceans. So how are our oceans doing nowadays?
Sadly, we are doing exactly what happened 250 million years ago in many ways. We're seeing real signs now that the ocean, which is normally really stable and has a big carbonate buffering system in it, so its acidity is very, very stable over long periods of time, is actually starting to get quite a bit more acid and quite hotter as well, and absorbing way more CO2 than we ever thought it could, and now it's not able to absorb much more. And we see this in all sorts of organisms which are sensitive to the change in heat and acidity in the ocean waters, especially things like reef corals. All of my friends who used to dive in reef corals 30 years ago when they were starting their careers and now at their end of their careers, they say those reefs that they dived on when they were young men are gone. They've all died off. And then there's just in the last week, there was a whole bunch of new studies showing how much the Australian Great Barrier Reef is dying off. And this is all due to what's called bleaching, which is when the temperature and the acidity of the ocean runs past a certain threshold. Reef corals, which are actually a symbiotic community of an alga that lives inside the coral polyp, break apart, and then the coral polyps lose their algae. And the algae are crucial because they're responsible for, of course, not only creating oxygen for the polyp, but also helping it make those big reefs. And so reefs all over the world are dying at a rapid rate. And this is something similar to what happened 250 million years ago with the great dying at the end of the Permian. We saw almost all the sensitive organisms go through a huge crash when apparently the ocean acidity rose really rapidly, and all the reef corals died off, and a bunch of other things that have been very successful through previous mass extinctions even did not make it. The most direct indicator of this is a group of small planktonic snails called pteropods, which make their shells out of mother of pearl, which is more soluble than the calcite that most shell organisms use. And they are now seeing signs of these things dissolving before they even reach adult size, because the oceans are now so acid that their shells cannot finish their development and grow to full size. They die off before they can get there. And so they're like a canary in the coal mine. They really are a warning sign that the oceans are going in bad trouble. Another place you see this is people who, especially here on the West Coast, who have things like oyster fisheries. You know, they put the oyster sprat, the fertilized eggs, on the bottom of the bay to try to get a new crop of oysters, and they're not developing because when their embryonic shells develop, the water is too acid and too hot, and they end up dying before they ever reach adult size. So there's lots of warnings that the ocean's in deep trouble.
So you mentioned the snails, the shells dissolving. I think you say that in your book as well, Donald?
I don't remember I mentioned that in the book, but yeah, it's only been the last couple of years that the pteropod issue has become really a problem, and a lot of people have noticed this.
Yeah, it is something that I've noted as well. And according to the statistics that I have looked at, if I remember correctly, 10% of coral reefs are, at this point, underwater ghost towns, and I think 60% are threatened.
Yeah,
does that sound about right?
And the fisheries also are suffering in all sorts of ways, mostly because things like coral reefs sustain most of the diversity of marine life on the planet, but also, of course, humans have been overfishing for a very long time, too, and that's a secondary impact on the oceans.
Yeah, it's perhaps also worth noting that there's this rapid increase in the number of dead zones in the ocean as well, which are zones that are have hypoxic conditions as a result of algae. So marine life, other than as far as I understand it, other than algae, simply can't survive.
Right.
And the largest one, I believe, is I think it's in the Baltic Sea, and it's about 27,000 square miles. But 400, I know a little bit more than 400 at this point. You know, around. I guess in the, well, it's really in every ocean. I mean, there are significant dead zones. There's also the Great Pacific Garbage Patch, which is this sort of island of, it's not actually an island you could walk on, but it's this pretty high concentration of small bits of plastic, which is in the center
plastic,
of, yeah, exactly. It's just south of Hawaii. And some people have estimated to be perhaps the size of the continental U.S. Some say that's too big, but it's really huge, yeah.
Yeah, I mean, so do the two of you, some people have a vision in their head of things get bad, they get better, they get bad, they get better, and kind of wobbles back and forth, versus we hit a tipping point, the ecosystem collapses, and we have a mass extinction. Are one of those, is there any question in your mind where we're standing right now?
No, I don't think there is, because we can look at the past when climate has fluctuated, when ecological changes have happened, and those small scale fluctuations, we can watch what happens and how things recover. And what we're seeing now is not similar to those small scale fluctuations. What we're seeing now is very similar to the great mass extinctions, where there's a big rapid shift and a lot of surprising things like the change in the ocean's acidity and temperature, and these are things that we don't see recovering from very quickly. And so that's why it's very likely to be a sort of mass extinction event as well.
Along these lines, exactly, there was a 2012 article published in, I believe it was Nature, that talked about how we understand the dynamics of localized ecosystems fairly well. And there are sort of two ways that an ecosystem undergoes total ruination. One, the authors call the sledgehammer effect, which the example that they give is if you had a bulldozer, for example, just sort of raise the whole area, then there's a sudden, as they put it, a state shift. So really a drastic transformation of the ecosystem. And the other one is much more insidious. It's that it involves certain critical thresholds that, by their very nature, involve surprising consequences. Beneath these thresholds, there can be various perturbations that are noticeable but not catastrophic. But then as soon as you hit this threshold, there's a radical and irreversible transformation of the ecosystem. So the people and the authors, over 20, I think maybe 22 authors from around the world, put their names on this article and said that by analogy, there's a reason to think that on the global scale, with respect to the global ecosystem, we could be pushing certain conditions up against a critical threshold, such that in a matter of decades even, there could be a complete transformation of the global ecosystem.
Right.
So within a single individual's lifetime, and they tie it into certain crucial ecosystem services, food production, pollination, so on, could be severely compromised, and it could be catastrophic and more or less irreversible.
Mm-hmm. Yeah, go ahead.
All right. So we've done a fair amount on climate change. We might go through this one a little bit quickly. This is slide number 13. We already know how big a deal it is. I guess, Donald, maybe can you I'd like you to do two things. One is maybe just start with telling us, who is Rachel Carson? What did the industry do to her? And what does that have to do with what's been going on with, say, James Hansen, Michael Mann, and scientists in general nowadays?
Right. Rachel Carson was a pioneering ecologist from the late 1950s, 1960s, whose book Silent Spring, which was published in 1962, is often considered sort of to be the launching point for modern environmentalism. And what she was doing was looking at studies which had been compiled, which showed that as more DDT was put in the environment, mostly by farmers to kill pests, the DDT was going up the food chain, so that the various organisms that ingested DDT were then fed on by higher predators and higher predators and higher predators, until things like hawks and other top apex predators, which feed on all these animals below, were getting so much DDT in their diets that their eggshells wouldn't be stiff enough to hold up, and they were having massive failure of their nesting because their eggs would crack before the chicks were hatched. And so there was a big decline in a lot of these types of apex predators, especially birds like falcons and hawks. And she pointed out that how these things work is that, all we do is something we think is fairly small scale, like spray our field for DDT, but over a large area, a lot of people doing this can have big problems. Anyway, Rachel Carson's book transformed the way the country thought. And by the 70s, environmentalism was so popular in this country that the Richard Nixon administration was the one that founded the EPA, and the various acts that were passed by Congress in the early 70s were like unanimous votes by Congress to enact all these various laws that enforce environmental regulations. And we've been in that world, until fairly recently. But what we're seeing, especially in the last decade or so, is a strange sort of backlash against environmentalism. And it comes from a weird area. It comes from this mostly hardcore capitalist libertarian idea that any restraint of business is bad, and therefore they have to find a way to demonize any kind of environmental thing, because that means government interference and government regulation. And so we've seen this over and over again, where they go to the extreme forms of demonization. In fact, shockingly enough, even poor Rachel Carson, who died in the late 60s, has been treated really badly by people who acted that she was a force for evil rather than a force for good. And they say, oh, well, if she hadn't made DDT banned, then all these people in Africa would have not caught malaria because DDT would have been available to them. But the point is, DDT was already being phased out even before Rachel Carson's book, because what happens is pesticides only work so long, and then the pests themselves, the various insects, the mosquitoes especially, evolve resistance to it so quickly that we're now at a point where we almost don't have any ideas where to go for another pesticide. So even if we brought DDT back, it wouldn't help because the insects out there evolve a resistance to it, and it wouldn't solve any problems. So that's a completely fallacious argument they make. And so what ends up happening a lot now is that a lot of these people who tell us what the scientific truth is about environment are now not only demonized, but actually persecuted. And so people like Michael Mann, who I believe you mentioned, was at the University of Virginia early in his career and was the famous author of the so-called hockey stick paper, which showed the last 1,000 years of temperature change on the planet. And they made a big effort to try to harass him and persecute him. The Attorney General of Virginia at the time, Ken Cuccinelli, was trying to subpoena every bit of his data, and basically just a fishing expedition to try to discredit him. Luckily, Mann is now at Penn State University, where there are no crazies there, but in Virginia apparently you still have some. And James Hansen, who's been sounding the alarm on global warming now for close to 40 years, routinely is picked on and beaten up by the media and by all sorts of right-wing things. And there are many places where there have been death threats against scientists. It's very scary. Instead of listening to what the messenger is telling us, even though it's not a pleasant message, we have a whole force out there that's willing to destroy us, just like they destroyed abortion doctors. They're really fanatical, and they're actually quite dangerous.
And Phil, maybe do you want to say something about the snowball during, remember in the winter, was that?
With
Which politician that was?
Inhofe?
Was that, yeah, James Inhofe, when he
Yeah,
showed up and
yeah.
said, so I guess global warming's fake?
Yeah, I think Donald talks about this as well in the book, if I remember correctly. Yeah, so he showed up one day. There's a video of this you could watch on YouTube. It was snowing outside, and he brought in a snowball and tossed it to his colleague, and as sort of a visual refutation of climate change. And it's not an isolated incident. I remember there was an event called that you no doubt experienced here called referred to as Snowmageddon. I don't remember what year that was exactly, 2009 or something. But at the time, or maybe it was 2010,
Yeah, I don't remember the year.
it was a record-breaking event here on the East Coast in terms of snowfall, and there were, I believe, record lows. But it happened to come during, at the time, the hottest year on record. And in fact, I think Donald adjusted this earlier. I mean, if you look at the past 16 warmest years on record, all of them have happened since 2000 except for one, which was 1998, and that was an El Nino year,
Right.
unusual El Nino year. But all the other ones, and it's
Right, and even that year of Snowmageddon was still one of those hottest, right? In terms of, so we look at weather versus climate and local versus global.
Yeah. I don't know why it's so hard for people to understand that there are local trends and there are global trends.
Right.
And sometimes the local trends go against the global trends. You can have a class with 20 students, and overall the grades are getting higher and higher, and yet there's one student in the class who's doing worse and worse. There's nothing incoherent about that. It's just averages on different sort of levels.
Right.
Yeah.
But I don't know if we had better scientific literacy, if that would make that kind of a gambit less, less likely to succeed. But all right, let's keep moving and get through as many as we can.
Okay.
Can you guys make any comments about the media's culpability in propagating some of these lies?
Do you want me to?
And what threat they're posing to the future?
Yeah. I would say the biggest problem with the media on this, of course, the Fox propaganda ministry, of course, is one of the biggest problems. But even the media that are not so obviously partisan compared to Fox, the big problem that media have in this country is that they believe there should be a fair and balanced presentation. One side and the other side is always presented. And the problem is, for many scientific ideas, there isn't another side except for a crackpot side, and they don't deserve to be given an equal hearing. So we never have the media presenting the Earth is flat and then a person who denies the Earth is flat and side by side, because nobody takes that claim seriously. But very often the media will put up a creationist and evolutionist side by side, which is a false equivalency. And the worst part of this, of course, is in the context of climate change. It's always some schmo who is in a climate denialist position, or a politician who doesn't know any science, versus Bill Nye the Science Guy, who almost always is their go-to guy to represent science. And Bill's a good friend of mine. He just laughs about this. And there was a very good episode of John Oliver's show Last Week Tonight, about a year ago, where he made a mockery of the silliness of equivalence of non-equivalent ideas. He said, there shouldn't be any debate. 99% of climate scientists have said it's settled. Why are we bothering to give these crackpots their time? But if we're going to give them a representative sampling of how this debate should go, instead of one face against one, which is the way it's usually done, Bill Nye versus some climate denier, he said, we're going to have a statistically accurate representation of how the climate debate should be done. And so he has Bill Nye and the climate denier initially on the stage with him. And then he gets two more stand-in actors, doubles, to come in and pretend to be the two other climate deniers. Then he has 96 other people come in all wearing white lab coats. Okay, now that is a statistically accurate way to show this debate. And of course, that ends the episode because it gets so loud that nothing can happen. And that's really the point, is that we should not be sitting there giving equal time to crackpot and fringe ideas that the scientific community has rejected, any more than we give flat earthers a fair amount of time.
Mm-hmm. Yeah, I was going to mention the John Oliver clip, because it's really quite visually striking to see the proportion, the difference in how many scientists believe in climate change and those who don't. It's also perhaps worth mentioning that to date, I know that there are at least 7 peer-reviewed studies that have looked at the degree of either uninformed or misinformed individuals, and found that Fox News viewers are consistently the most misinformed. Yep. About issues from climate change to the Iraq War to, Obama's birthplace, really quite elementary issues. And yeah, one study found that there's basically a linear relation between how much one watches Fox News and how wrong some of their views are. And also another one found that, I believe it's from the University of Maryland, found that individuals who don't watch any news are less misinformed than people who watch Fox News.
And so I think I'd asked Donald this before, but so is there a way to start to try to hold them culpable? Like if this is a purposeful misinforming and it works against our public interest?
Now, that's a hard
I don't
one.
know. I don't really have a good answer. I'm sorry, Donald?
It's funny. In Canada, the equivalent of Fox News went out of business. So it's doable. I think it's something that reflects the political times. And I think when that generation of old, cranky, bigoted, denialist, anti-scientists that feed Fox News start to gradually die off and lose political power, I think Fox itself will probably start to fade. Its viewer numbers are already down just compared to a few years ago, and even Rachel Maddow beats them out almost all the time now. So there are signs of hope that this is not going to stay much longer.
Okay. All right. Donald, this one's for you also. This can just be a quick one. We're at number 15, credential mongering. You talk about, and Phil alluded to this, with PhDs now, you'll see that plastered on a lot of denialist papers. What is a PhD? How do they build those?
The challenge you have to face, you have to watch out when people claim to be experts, whether their expertise is relevant to what they're talking about. And this is the typical problem when you deal with a science denier, especially creationists, because what they'll do is they'll flout their PhDs on the cover of their books and every place their publicity's there. And my rule of thumb is that they flout a PhD on the cover of their book, beware of the contents. Because those of us who do have PhDs will almost never advertise our title as a way to establish credibility. It's the credibility of our arguments ourselves that have to stand up by themselves whether or not we have a PhD. And people get the impression somehow that PhD makes you magically more intelligent than everyone else and better informed. But actually, those of us who have PhDs know it sort of does the opposite, because what you do is end up becoming so specialized in one narrow area of research that you have to focus on in order to finish the process and jump through all the hoops and get the thesis written and all the defenses and things to do with it. You tend to lose a lot of your breadth in other fields because you don't have the time to be very informed about other stuff. But more importantly, is remember, when you have a PhD, you only have it in the subject on which you are trained. And so you're only qualified to talk about whatever your training is in. And when you deal with someone like the creationists, for example, they'll have Dwayne Gish, who was a biochemist trained in the 50s, and Henry Morris, who was a hydraulic engineer, talking about fossils. Not one of them has ever spent any time learning paleontology. They could not tell you one bone from another, yet both of them are written all about fossils as if they know what they're talking about, and they don't. And so I say to audiences when I say, well, if you were taking advice from them, then why did you ask them? You might ask them whether they can fix a car engine or write a symphony. Their training isn't relevant to that either. They're not just all-purpose experts just because of a PhD. PhD only means you're an expert in one area, and if you speak outside the area, you have to always be aware of your limitations. A lot of people often don't.
And I think, oh, go ahead.
Oh, I'm sorry. My understanding also is that there are a number of for example, intelligent design paladins who went to school, who held certain beliefs and then went to school to get a PhD. I think Michael Behe is an example of this.
Yep, and Kurt Wise, there's several others as well, yes. You can go all the way through to finish a PhD, but if you come in with a hardcore creationist viewpoint like Kurt Wise and a couple others guys do, our minds are so closed that even though Kurt Wise is actually Stephen Jay Gould's student at Harvard, he learned nothing. He just did it in order to get through the process and get a Harvard PhD under Stephen Jay Gould so he could rub that in our noses for the rest of his life. And the creationists always throw him up there as a PhD paleontologist at Harvard trained by Stephen Jay Gould as refutation that all paleontologists agree on this. Well, he never actually bought into paleontology to begin with. He was going through the motions from the beginning.
Yeah, I was going to say it's also a lot of Cold War nuclear physicists decided to take anti-environmental approaches on everything.
Right. Climate deniers' lobbies are run by, as you said, nuclear physicists who when the Cold War ended, they had to figure out something else to spend their energy on. That's when they got into beating up on environmentalism and anything which restricted the government. Because once the Cold War ended, their primary interest, as Orestes and Conway points out, was trying to push capitalism. And so that's where they devoted their energies to fighting the climate change evidence and fighting the ozone hole and fighting all this stuff. They all became all-purpose anti-environmentalists, and yet they're all trained in nuclear physics. None of them have any relevant training to atmospheric science, climate science, or anything like that. And yet, because they had PhDs in nuclear physics, everyone thinks they're all-purpose geniuses.
Right. So Merchants of Doubt is a great book by Naomi Oreskes and Eric Conway, I think, if anybody's interested in that. All right. Let's talk about nuclear threats. So why don't you start off, and there's several aspects to talk about with nuclear threats, the benefit of nuclear energy, the risk of it, but I'll let you take your pick as to where you want to start for existential threats.
All right. Yeah, so a number of current existential risk scholars would classify nuclear war as one of the most significant immediate threats. There are others. A lot of people genuinely recognize superintelligence as a greater long-term threat to human prosperity and survival. But more immediately, it's the nuclear threat. The Bulletin of Atomic Scientists, I referenced them earlier as well. They have a science and security board with a number of experts in policy and science who identify climate change and nuclear conflict as the biggest threats right now. So it's certainly, the Cold War is over, which is certainly a good thing. The Bulletin of Atomic Scientists maintains a doomsday clock, whereby 12 midnight indicates some sort of major global catastrophe. And so they move the minute hand back and forth over time to indicate our sort of collective proximity to a catastrophe. And so the furthest away it's ever been is 17 minutes from midnight, and that was in, I believe, 1991, at the very end of the Cold War. The closest it was 2 minutes to midnight, and that was in 1953 when both the US and the Soviet Union detonated hydrogen bombs for the first time. Hydrogen bombs being much, much more powerful than atomic bombs. So today, the clock sits at 3 minutes before midnight. So it's really quite close, and yeah, there's an issue of nuclear terrorism on the one hand, which many experts, it's really quite stunning reading the literature in exactly the way that sort of reading the literature on biodiversity loss is quite surprising. Nuclear terrorism experts, assign really high probabilities to some sort of nuclear catastrophe happening as a result of Al-Qaeda or the Islamic State has explicitly fantasized about getting a nuclear weapon from Pakistan and sneaking it through South America, Central America, and into the US. And then on the other hand, of course, there are state actors like North Korea, which has many times threatened nuclear war against the US. I believe one of the last times was with the movie, the James Franco movie, which ended up resulting in one of the biggest instances of cyber terrorism or cyber crime. But initially the threat was if that movie's released, depicting the North Korean leader getting assassinated, then they will launch an all-out nuclear war against the US. But there's also, there's growing tension with Russia, Russia and the US, Russia and NATO. Even the Russian prime minister recently referred to the predicament that we're now in as a new Cold War. So there's reason to be concerned about, tensions between state actors, and then also this sort of ongoing, really non-trivial risk from non-state actors, getting hold of a nuclear weapon or even constructing a radiological weapon of some sort.
And Donald, can you take the other side of that and talk about, what are your feelings about pursuing nuclear power on the whole, given the reality of climate change and the risks associated with using nuclear power?
Well, all forms of extracting energy from the planet have their ups and downs, their pluses and minuses. They have some certain amount of waste involved as well as a certain amount of benefits. And it's coming to the point now where we realize how bad the consequences using fossil fuels are and how much they're destroying this planet. And so we now are going to have to face the reality that, yes, nuclear reactors are not the greatest thing around because they do produce waste we have to be very careful with. But we're now producing way more waste, which is actually destroying the planet directly rather than kind of waste that we could produce but could probably store. And so I think we really have to come to the point recognizing that as long as we do it very carefully, there are lots of ways that nuclear power can be a much better choice than pouring pollutants into the planet. And the irony is really it's only a problem in this country. Most of Europe has nuclear reactors all over, especially places like France, and they've never had any problems and they don't seem to have any worries about it. And other than the problem with the Fukushima reactor in Japan, which was hit by an earthquake and a tsunami, the Japanese have a good safety record, but that was an extraordinary event. So, the rest of the country is not so gun-shy about nuclear power as we are. It's just taking a longer time for us to come to recognition that no system is perfect. All energy things have their pluses and minuses, and you have to weigh those, and you also have to take into account the fact we haven't weighed the effects of burning coal and oil and gas as a serious risk as much as we should have, and now it's time to think about it.
Okay. All right. So we're going to try to do this for maybe another 10 minutes. If people have questions, just raise your hand so I'll know how many are out there. We'll try to get through some slides, but also try to leave some time for questions. So going on to the next, we're going to talk about infectious disease. Donald, I'm going to give you a chance to respond about the anti-vax movement and alternative medicine. Phil, if you can start, how much of a problem has infectious disease been historically, and are we about to have this licked, or do we still have a lot of work ahead of us?
So most people don't realize just how catastrophic infectious disease has been in the past. So a classic example is World War I, lasted from 1914 to 1918, and resulted in really significant loss of human life. But from 1918 until 1920, just 2 years, at the very tail end of, in fact, it was the close proximity of huge number of soldiers was conducive to the spread of Spanish flu. And Spanish flu resulted in roughly, depending on the estimates you might look at, about 63 million more people died as a result of Spanish flu in those 2 years than died in World War I. So you can, and I do a bit, run the numbers in one of the chapters, looking at what the Black Death, resulted. It was the same as the Mongol conquests, as World War I plus World War II plus Crusades, and several other really significant battles that sort of have a strong threat, a strong fear valence, I would say, when we sort of look back over history, whereas Spanish flu, most people haven't even heard about. So it really is quite significant. And with respect to anti-vaxxers...
Well, I'm going to have Donald do anti-vax, but I want you to do, so where do we stand now? Like, should we say our science can handle all this and we're safe now? Like, we have the Zika virus is coming out. how concerned do we still need to be? Do we have enough antibiotics in the line? Are we funding research into that?
Yeah, several studies have shown that the US is very ill prepared. Although I have to say recently some of the outbreaks, like with SARS, we've internationally done a pretty good job. But a crucial point, and this gets to more of a futurological issue that I discuss in the book, is that germs that evolve in nature, such as the Spanish flu or poliovirus or Ebola and so on, these oftentimes, there's a kind of check in terms of their lethality. Well, at least with relation to their lethality, the incubation period, and there's several other properties. Because if you as a virus kill your host too soon, you won't have a chance to find another host, to therefore propagate. So you'll be naturally selected against. So oftentimes in nature, you don't find the type of germ that might wipe out a whole population in a day, or something of that sort. But when it comes to genetic engineering, biotechnology, and synthetic biology, there's no the selfish genes that sort of rule the biological world are completely unnecessary. You can design, in other words, you can design pathogens specifically to kill. It doesn't matter if they perpetuate in the environment. So, there was a very comprehensive and insightful document that was released a year ago or so by the Global Challenges Foundation and co-authored by Stuart Armstrong at Oxford University, where they talked about we're now at a point where it's quite plausible that you could take like the lethality of rabies, the incurability of Ebola, the contagiousness of the common cold, and the incubation period of HIV or something, and combine all these properties into one. In fact, we have historical examples of this. There were famous cases of Australian geneticists who were trying they were modifying the mousepox virus, and they induced a certain tweak to the genetic code, and it resulted in this hyper-virulent version of the mousepox, such that even the mice in their lab that were vaccinated against the mousepox virus all died. So, and part of the reason that was frightening is because the mousepox virus is very similar to smallpox. So it's suggested that it may be possible to modify smallpox to make it much more lethal than it currently is.
Right, and you also point out in your book that these are things that you don't need a mega lab to do this anymore. It's getting to the point where some of this is going to get relatively simple, that individuals with a little bit of background can do it.
Yeah, so this is a concern. I mean, the potential benefits of advanced biotechnology and synthetic biology are genuinely extraordinary. I mean, there could be all sorts of cures for disease. There could be ways to extract carbon dioxide out of the atmosphere to try to reverse or to mitigate climate change. But at the same time, the very same technologies could be used for nefarious purposes. Furthermore, a lot of laboratory processes are now automated. So it literally takes, you have to hit a button to perform some sort of manipulation that, 15 years ago, only the top scientists in the very best labs could do. And also these technologies are becoming increasingly affordable. So there's like a biohacking movement where people, who are interested in sort of tinkering with the building blocks of life, usually, quite explicitly for the purposes of benefiting humanity. It has resulted in laboratory setups that cost, a couple $1,000s. And again, many of the devices are automated, but even then, there's information online. It's not too hard if you're a motivated autodidact.
If you want to reproduce a virus.
Yeah, exactly. So certainly there could be a terrorist that attempts to do this. The Islamic State there's a laptop recovered or taken from them in 2014 that had some pretty detailed plans about how to weaponize the bubonic plague. And frankly, if you talk to a lot of experts on bioterrorism, many are surprised that there hasn't been a larger. In 1985, I think there was a bioterrorism attack in the U.S., but it wasn't significant. It had salmonella, if I remember correctly. But yeah, so it could be really quite. Spanish flu was bad, but it's not unreasonable to imagine a situation in the future which
We
could
could
be even more-
engineer something really catastrophic.
Yeah.
All right, so Donald, on number 18, infectious disease part 2, so far we haven't had horrific bioterrorist attacks, but we have had the anti-vax movement
Yep.
and complementary and alternative medicine. Can you talk about that movement? Also talk about a little bit the fact that we have the NIH has its alternative medicine wing. How does that complicate issues for people trying to just understand the information?
Right. Yeah, the irony is that at the moment right now, we have so successfully banished many diseases, especially childhood diseases, that used to be massive killers even a generation and a half ago, that people have forgotten what a safety net they produce around us, that we are no longer seeing large numbers of cases of polio and measles and mumps and all the rest, and rubella killing kids, which used to happen even just in the early part of my generation on a routine basis. And so the sad part of this, of course, has led to what's called the anti-vax movement, which is all these younger generation people who've forgotten how protected we are by these vaccines, getting this misinformation from a fraudulent doctor in Britain that somehow vaccines cause autism, and then all of a sudden going in the other direction and rejecting this very hard-won battle over all these dangerous pathogens in order to just follow this false idea that somehow their kid won't get autism, or the kid was given autism by some kind of MMR vaccine when they were 2 years old. And so we've seen that it's a sad sort of a consequence of possibly scientific illiteracy, but also just basically taking for granted our hard-won victories over death and disease, that we see these people now bringing those same ages of death and disease back and allowing large populations of kids to get to the point where they don't have herd immunity anymore because a very small percentage are vaccinated. When you drop something like 60% vaccinated or less, then there's no protection against herd immunity. And so the result is that when a virus gets around, it spreads quite quickly. And then you had the famous measles outbreak at Disneyland last year and a bunch of other cases all over the country, in a country like ours, which should be almost 100% protected. And so it feeds into the general point you were raising, which is that, we got all this amazingly competent medical community out there now, which has accomplished so many things, and yet people simply don't want to listen to them, and they listen to all these quacks out there that call themselves alternative medicine. And as Tim mentioned, in Australia points out, alternative medicine, the only difference between that and real medicine is that medicine actually works. And alternative medicine is things that haven't worked so far. And so all these people buy into all these various quack remedies, whether it's acupuncture or chiropractic or all these other things, and yet they wouldn't be there alive to even enjoy these benefits if it weren't for the fact they're protected by real medicine. Not to mention the people who are faith healers and don't even for religious reasons reject medicine and then let their kids suffer needlessly and die, all because they don't want to accept what we have all won so hard over the last century in the medical community.
And can you say just a word about the fact that the NIH has its own branch for alternative medicine?
Yeah, that's politics at play there. It doesn't have anything to do with science at all. It's just that, the political forces that control the budget of the NIH are not necessarily always in favor of science. And so we have people in Congress, for example, who push on the anti-vax issue. We used to have one Congress in particular, Dan Burton of Indiana, was a hardcore anti-vaxxer and wasted lots of taxpayer dollars having hearings about anti-vax. And then right this week, they have a film festival in Tribeca in New York where there's an anti-vaxxer film, propaganda film out there that's being become very controversial because it's being aired and it's all full of scientific garbage. So it's to me, it's really sad because people have taken for granted and forgotten how bad things were only 2 or 3 generations ago, when routinely most of the children that were born died. I mean, Charles and Emma Darwin had 10 children, 3 of whom died, and that was fairly typical. And they were relatively well-to-do Britons in their generation. It's a death in childhood and death of women in childbirth was a very common thing, and yet we've nearly conquered that in all the Western world where medicine is modern, and now we're throwing away that hard-won gain for these really silly ideas that people have forgotten how far we've come.
Yeah. All right. I think we're going to do 2 more slides, and then we're going to have to call quits and see if there's some questions here. Let's do these really quickly, because I feel bad if I didn't let you say something about artificial intelligence, the future stuff. Talk about our children might kill us or save us, and our parents might unplug us.
Okay, so very briefly, I mentioned before, superintelligence is considered by many individuals who study existential risks to be perhaps the most significant long-term threat to human survival. So part of the issue is that This has nothing to do with robots marauding through cities with guns. It's much more subtle than that. On the one hand, it could be the case that there's some sort of artificial intelligence, artificial machine that does have malicious intentions and strives to destroy humanity, but that seems unlikely. The much more probable issue is that you have essentially an algorithm that has the capacity to problem solve. In other words, to manipulate the world around it in order to achieve its ends. The idea is that if those ends, if those values that motivate the AI differ from ours in even slight ways, the results could be catastrophic. So a famous example given in the literature is a paperclip maximizer. So it has one goal, which is to maximize paper clips. And this goal perhaps might sound benign, but it very likely would turn out to be existentially catastrophic for us because we are composed of molecules and atoms which it could harvest to build more paper clips. So other examples might be, if we told the AI to make us happy, and it notices that we smile when we're happy. So it implants certain electrodes in our cheeks to contract certain muscles to make us appear as though we're happy. It's not exactly what so you go in and you modify the code to say that's not exactly right, and then it says, well, how about this? Let me just implant some electrodes in your brain. And, so there's an artificial, to the pleasure centers of your brain, so there's an artificial sense of contentment. That's not exactly what we mean either. So it turns out to be really, really difficult to determine what values you would need to instill into an AI that has human level or superhuman level ability to solve problems, to achieve its ends. So that's essentially the main issue with superintelligence.
Okay.
Yeah.
All right. And this is the very last one for Donald. Do you see unbridled capitalism as the engine that pulls all of us forward, or something that turns us into cogs? Is this a threat that the way capitalism truly works, if it's not regulated, takes away the individual political power?
Yeah, this issue has gotten really complicated because we now have one political party here that's willing to break the rules of not just science, but even break the rules of common rationality in order to push a dogma that's so contrary to reality that's pretty scary. And we have a political candidate out there who basically flaunts almost all rational thought and doesn't give us any answers, and then Donald Trump, of course. So it's really scary that kind of thing can achieve as much power as it does. But I have a little faith, actually, that ultimately the voters will reject these people when they get too far along in this dangerous path out of reality. And especially because although capitalism can be, source a lot of evil, eventually things come in where enough people get tired of the excesses of capitalism that they rein it in. And this happened, of course, at the end of the 19th century, and Teddy Roosevelt and the others finally got regulation in on the golden age of unbridled rampant capitalism. I think it will also kick in here as well. And then remember, we're also players in a world community. The U.S. does not act alone, and that we do have international agreements and international organizations to which we're more or less bound to. And so things like, for example, the ozone hole, when it first emerged as an environmental problem in the 1970s, it was hard to imagine that we could solve this, but it was solved. By the 1980s, we had the Montreal Protocol in effect, and we banned the production of chlorofluorocarbons, CFCs, and the ozone hole is no longer increasing. It's going to take a long time for it to recover, but we managed to have an environmental movement that basically was international and that all the countries of the world have managed to enforce, and the production of that product disappeared. And likewise, they say, oh, well, cap and trade doesn't work. Well, actually, cap and trade is already in effect when it comes to acid rain. All the various power plants in this country that have potential producing acid rain already have cap and trade constraints on them. So the government makes sure that we don't produce too many of the various types of acids that will then cause acid rain. So there are solutions to this, and it's going to just take a little more political will and recognizing that not all the countries in the world are hardcore capitalists like we are, and they're bound to us by international agreements as we are to them, and they could act as a brake so that we don't end up going too far in that direction.
Okay, well, that's somewhat hopeful. Are there any questions from the audience that we want to end with? All right, well, I'd like everybody to thank Donald Prothero, Phil Torres for spending the afternoon with us.
Thank you very much.